Hello everyone, my name is Tony Burke. I'm a networking instructor and I teach Cisco ACI as well as other networking courses for Lumos Cloud. I'm a CCSI, that's a Cisco Certified Systems Instructor, number 32063. I'm also a skydiving instructor and I've been teaching primarily for the past 12 years. For the past couple of years I've been teaching primarily ACI, but I'm also familiar with other environments. This particular video is going to cover how to troubleshoot with Cisco ACI in a VMware environment. Now, a lot of people are still learning ACI. It's an unfamiliar territory for many people. And those people who are network engineers tend to also be unfamiliar with VMware. And that's just a recipe for frustration. So a lot of these SDN products, whether it be from Cisco or VMware or whoever, they're really great until you can't ping your default gateway. And then what do? So the skills that we learned as network engineers from like traditional CCNP routing and switching training and so forth, they don't really prepare us for how to troubleshoot these environments. Although they really kind of do, because there's a lot of the same basics, MAC addresses, IP addresses, packet flows, etc., still apply into these software-defined networking solutions, into these data center fabrics. So we're going to go over these and how to troubleshoot in a VMware environment, and I'll show you my step-by-step progression. I'm going to show you how to troubleshoot through VMware vSwitches, through Blade switches, as well as Cisco ACI. So a lot of people get lost when they're trying to troubleshoot environments like ACI and VMware, especially the combination of the both. So what do you want when you're lost? You want a map. So I created this map here. Now this map covers the entire environment for ACI. There's three distinct realms that we tend to work with Cisco ACI. First, we have the logical model. That's where we define things like bridge domains and APGs and subnets. We have the concrete model, or the access policies. So that's how we grant physical resources, physical interfaces and VLANs and so forth to make them accessible to tenants. And then we have the environment, we have the VMware environment, we have the Blade switches, whatever they may be, and then as well as the connectivity up to the leaf. This particular troubleshooting guide is going to cover just the environment, or primarily the environment from the leaf on down to the VM itself. So in this environment that I'm going to show you, I just want to give you a quick overview of what it looks like. We've got one spine and two leaves, leaf 1 and leaf 2. This is a lab environment, so of course we're not really concerned about redundancy. Each leaf is plugged into a single fabric interconnect. Again, those would typically be cross-connected with VPCs, but again, it's a lab environment, we don't really care. Each fabric interconnect has a single connection into an ESXi host connected to a VM NIC. In this case, we're using Tenant 2, and Tenant 2 has two hypervisors, an ESXi host that's on 10.206.254.52 and 10.206.254.72. Those are the management IP addresses of those hosts, and typically how we identify ESXi hosts in this environment. We're dealing with one bridge domain called web, and the EPG is also called web. The subnet for that bridge domain is 10.211, that's the default gateway for the hosts. And the web servers are web 1 T02 and web 2 T02. And they're at 10.2.1.11 and 10.2.1.12 respectively. We've also got a hypervisor. Now we've got a vSwitch that's that's instantiated. So this is a distributed virtual switch. It's instantiated in both ESXi hosts. And we've got one particular port group that we're dealing with, and that's the web port group. Both web 1 and web 2 are connected to these port groups, although they're on different hypervisors. Those port groups translate into EPGs in the ACI environment, and they're going to be connected via VLAN. So we're going to troubleshoot all of this. So in this scenario, a trouble ticket comes in that the web servers, those particular VMs cannot get to their default gateway, and they can't get to the outside world. So we're gonna troubleshoot that process. Now, most of you probably will have what I call the usual suspects. In any given environment, there's typically the same problems have the same root causes, or a lot of the same problems have the same root causes. And when an issue comes in, you'll hear the symptoms and you'll recognize what the likely root cause is, and that's going to get you to a resolution pretty quickly. But there's always those cases where the usual suspects don't pan out. So now we need to go through some sort of system where we just verify every little step of the way, and that's what we're going to do here. We're going to start from the bottom and go to the top. When I say the bottom, I mean we're going to do the VM first, and we're going to check the VM itself, verify the configuration on the VM. We're going to go up to the VM configuration in the hypervisor to the port group, to the vSwitch, to the uplinks, to the blade switch, to the leaf. So first thing is we're going to check the VM. We're going to do troubleshooting and verification of the VM. Now I say troubleshooting and verification because sometimes it's actually not the network. I mean, some of you have probably maybe have been in situations where it wasn't exactly the network's fault, but we still had to prove that it wasn't. So we're going to verify every step just to make sure that everything is configured correctly, because it could be just a simple misconfiguration. So first off, whenever we're troubleshooting a physical host, so most of us in networking have dealt with troubleshooting physical hosts. There's a couple of things that we do when we troubleshoot a physical host. For one thing, we verify that the IP address is correct. We check the MAC address because we might want to have that MAC address a little bit later, so we're going to make a note of that MAC address. We're going to check to see that the system has the correct default gateway, and if there's any static routes that have been added. Maybe there's some erroneous static routes. Typically, most systems don't have static routes, but sometimes they do. Have there been any erroneous static routes that have been added? Is the cable plugged in? That's a big one, of course. Is the port configured for the correct VLAN? And we're going to check the ARP table to see if we can even resolve the MAC address of the default gateway. So the same is true for a virtual machine. So that's not any different. We're going to check the IP address. We're going to note the MAC address. We're going to see what the default gateway is. We're going to check for any configured static routes and see if any of them are erroneous. Is the cable plugged in? Now, of course, it's a VM. It doesn't have a physical cable. There is a connected checkbox that we can use to see if the virtual machine has been plugged into a virtual port group. Basically, see if the cable is plugged in. We're going to see if the port group is on the correct VLAN and if the VM is configured for the correct port group. And we're going to check the ARP table just like we would with any other system. So if you have access to the system, there's a bunch of commands you can run to verify all these steps. If you don't have access to the system, what I highly recommend is you give a list of commands to your VMware team, your server team, whoever it is, so that they can quickly run these commands, put it in a script. It takes like 2 seconds so that they can put the output of these commands. Typically, they won't have access to the actual SSH or so forth, or usually they won't if there's a network connectivity problem, but they can get into the VMware console and then do maybe a print screen or a screen capture and then put it as part of the ticket. So if it's a Linux system, there's I have here listed the commands that I typically would have someone from the VMware team run on a given host that's having troubles. On the left, we have the older Linux style commands, and on the right, we have the newer Linux style commands. They both do the same thing. The older Linux ifconfig utilities are a little bit older, the ethtool utilities, and then the new IEP utilities are a little bit newer, but they both do the same thing. We've got ping, just to see if we can ping our default gateway. Now here's a little tip you may or may not be aware of. In ACI, you should always be able to ping your default gateway, assuming you have the default gateway configured correctly and you have the layer 2 access to that VM configured correctly. Even with contracts, ACI will not prevent a host from pinging its default gateway. In fact, if you have a host configured correctly in a VRF, you can ping the default gateway for any other bridge domain in that VRF. There's no contract cannot prevent that from happening. So even though you need contracts for most communication in ACI that goes beyond the EPG, pinging your default gateway is not prohibited, which is a really nice troubleshooting tip. So if you can't ping your default gateway, then either the default gateway is misconfigured or you've got some sort of layer 2 problem, usually the latter, but sometimes the former. So first of all, we're going to try to ping the default gateway, see what happens. We're going to verify the IP address is correct on the host. We're going to verify that the link is up. We're going to look for that up link light. Of course, it's not really a link light, but it's a faked link light in the virtual environment. We're going to check make sure the default gateway is configured correctly, and we're going to see if there's any other static routes in there. Some of them might be erroneous, and some of them might be necessary. We're going to check the routing table and check that, and then we're also going to check the ARP table to see if we can even resolve the MAC address of the default gateway. And that should give us an indication whether or not we have layer 2 connectivity up to the leaf. We have the same commands for Windows, slightly different, but they produce the same results. And again, if you don't have access to these hosts, I recommend giving these commands to your virtualization team and saying, look, if you're going to open up a ticket, save us both a bunch of time, run these commands, because all I'm going to do is when you open up the ticket, I'm going to kick it back saying, please provide the results of these commands. If they can provide them ahead of time, when they first open up the ticket, it's just going to speed up mean time to recovery. So let's say that the VM itself is configured correctly, the IP address is configured correctly, but we still can't ping the default gateway. We're probably not resolving its MAC address through ARP. So let's go ahead and verify the VM configuration. So this is the outside of the VM. VMware is a little bit tricky these days because right now there are 3 different interfaces in common use. We have the FAT client, we have the Flash client, and we have the HTML5 based client. So the FAT client is used commonly in older vSphere instantiations and vSphere installations, but there's still plenty of them out there. The Flash client was used for whatever reason. When VMware decided to move to a web-based interface, they went with Flash. I don't know why they did that. At least it wasn't Java. Slightly better than Java. Anyway, they have been migrating to HTML5, so there's basically three interfaces. I have screenshots here for the FAT client and the Flash client, but the examples that I do live a little bit later are going to be via the HTML5 based client, so at least we have that. No matter the web user interface or whatever interface that you're using, you go into the configuration of the particular virtual machine, and we're going to check to see that it's connected. That connected means that it's plugged in virtually to the virtual port on the port group. If that checkbox is not there, that means the virtual link light is out, and we need to make sure it's connected. There's also an option for connect.startup, which means if we don't have that selected, if you power down the system and power it back up again, it won't reconnect. So we need to make sure that both those checkboxes are there. And again, those checkboxes are in all 3 of the current interfaces, the old FAT client, the old Flash client, and the current HTML5 based GUI. So we checked the outside of the VM, we checked the inside of the VM, we verified the IP addresses and so forth are correct. We checked the configuration for the VM itself. We made sure that it is in the correct port group. So that's also important. We need to make sure that the VM is in the correct port group. And all of that checks out. It looks like it's all correct. So now we need to move to the vSwitch. This is where people in the networking world get a little confused or get a little panicky because they're not familiar with this environment. So just to lay it out, there are 2 distinct switches in the VMware environment that we typically see with ACI. NSX is something completely different, and that's a different training regime and so forth. But here we're talking about either the standard virtual switch or the distributed virtual switch. They're both 2 very basic, simple layer 2 switches. The difference is the standard virtual switch is a switch that's configured individually on each ESXi host, where the distributed virtual switch is configured in one place in vCenter, and then that configuration is pushed out to each individual hypervisor. And the hypervisor is called ESXi. So you can use either one with ACI. If you want to have the policy orchestration, so that means when I create an object in ACI, it gets pushed down into VMware, or I create an object in VMware, it gets pushed up into ACI. That requires the distributed virtual switch, which requires the Enterprise Plus licensing. But if you don't have any integration configured between ACI and VMware, that's okay. You can either use the distributed virtual switch or you can use the standard virtual switch. And you just configure those 2 items separately without any coordination of policy. And that's fine. A lot of shops still do it that way. Now, whether or not it's a distributed virtual switch or a standard virtual switch, the basics of the virtual switch are the same. We have at the top, we have a couple of uplinks. Just like any other switch, our ACI leaves, they require some uplinks, just like a virtual switch requires uplinks. We have the vSwitch itself, typically just a software construct. We have the port groups. So the port groups are what we would call VLANs in the networking world, or they translate basically one-to-one to VLANs. Those are broadcast domains, very similar to VLANs. And the port groups have virtual ports, and the virtual ports get plugged in the VMs via their VNICs. There's a little bit of confusing terminology here. The physical uplinks are called VMNICs. Those are the uplinks on the vSwitch, and the NICs on the virtual machines are called VNICs. Now, if you would have said VMNIC to me without knowing anything about VMware, I would have assumed that was the NIC on the VM. That is not the NIC on the VM. The VMNIC is the uplink, the physical interface. The VNIC is the virtual interface on the VM. Don't ask me why they called it that. That's what they called it. So the uplinks are exclusive to the vSwitch. So we generally don't have vSwitches sharing uplinks. In some cases we might, but most of the time a vSwitch, especially a distributed virtual switch, has exclusive use of that physical interface connecting up to the leaf or the blade switch typically. So those are some vSwitch basics. The vSwitches do not do any kind of spanning tree. They either do an 802.3AD link aggregation, what we would call port channel in the Cisco world or VPC in the Cisco world, or they do what we call MAC pinning, where they pin a specific VM to an uplink. But we'll get to that in a minute. We're also going to verify the port group. So the first thing we're going to do once we get past the actual configuration of the VM itself is we're going to verify the port group. So that's the part that's closest to the VM, and I'm going to show you what that looks like. So we're going to go into vCenter here. So we have tenant 2 in ACI, and currently the ticket comes in that Web 1 cannot connect to anything outside of its port group. It can't ping its default gateway. It can't get to the outside world. So I know from the documentation that the default gateway is 10.2.1.1. So I'm going to try to ping that, and nothing comes up. So I'm going to start I've checked my usual suspects, the things that maybe normally come through, or maybe this doesn't match any symptom I've normally seen before. So I'm just going to do it the hard way. I'm going to do it the procedural way. I can't ping my default gateway. So the next thing I'm going to do is I'm going to verify my IP address. So IPA in this particular Linux instance, and it shows me that my IP address, this may be a little hard to see on your screen, I'll try to zoom it in, is 10.2.1.11. That is correct. And also I see over here that the state is shown as up for the interface. The NIC is called ENS160. It's the way that Linux maps and names these interfaces. You should call them Ethernet 0, Ethernet 1, etc., but now they use a different naming convention. So the link is up, which means we are connected into a virtual port. It may not be the right virtual port, but at least we're connected into a virtual port and it shows connected. I'm going to check for the IP routing table, so IPR, which shows me the routing table. I do have a single default gateway, and I have no other static routes, which is correct for this configuration. So that's 10.2.1.1. That's what we have from the documentation. I'm going to check the ARP table, so IPN for IP neighbors. And it shows that I have a stale entry for the other host. See if I can ping the other web server 10.2.1.12. I can't ping that either, so I'm going to do IP neighbor again. That MAC address doesn't look correct, so but the one we're looking for right now is 10.2.1.1. And it shows that ARP has failed. So I've done an ARP request who has 10.2.1.1 and nothing has responded. So it looks like I've got some sort of configuration issue between the hypervisor and the leaf. But I verified that everything is correct on the system itself. So I'm pretty much done on the VM itself. So I'm going to go into VMware. So this is the VMware environment. I'm going to check the configuration of the VM itself. So in this particular interface, this is the HTML5 based interface for vSphere 6.7. Here's Web 1 T02, and I'm going to check configure, edit settings, and I see network adapter 1 is in black hole. So that is incorrect. That is not the right port group. The right port group is Web 1. So I'm going to go to Browse. The correct port group is web. So T02, that's the tenant name. Web app is the name of the ANP, the application network profile, and web is the name of the EPG. So that's what I want to be on. So I'm going to click OK. It does show connected. And if I drop that down, it'll show connect at power on. I just wanted to verify that. That's correct. I click OK. So I'm going to go to the web server and I'm going to see if that works. Did that allow me to ping my default gateway? Well, that's the default gateway, 10.2.1.1. Still can't ping it. Now, that definitely was a problem. In fact, I was connected to black hole. Black hole is an isolated port group that I can put hosts if I'm making changes to different port groups or whatever. and it means that that particular host is isolated. It's good for things like security. Maybe I bring up a VM, it's contaminated or it's been compromised and I don't want it to be able to communicate with anything, but I need to bring it up so I can do some log checks or whatever. And there's other reasons why we might put a VM in black hole. In this case, we put a VM in black hole because work was being done on that port group. And maybe someone just forgot to put it back onto the correct port group. So it definitely was not on the correct port group. But obviously that wasn't the only problem. Now, many times, I'm sure you've run into this before, many times you run into a situation where you fixed a problem, but it wasn't all of the problems. So this is the case here. We fixed a problem, but it looks like it wasn't the total fix. So one thing I can do is I can go into the other host and I can check. So these two hosts, Web 1 and Web 2, should be on the same port group. I'm just going to verify that it's on the right port group as well. Click Edit Settings. It's also in black hole. Now what I'm doing this for is I'm going to make sure, I'm going to see if they can ping each other. So go back into Web 1. I'm going to try to ping .12. That's the other host. I can ping the other host. So at least the port groups are working correctly. They are actually on two different hosts, and I'll show you how I know that in a little bit. And that's going to give us some information so that some layer 2 is working. Now, how far that's going, is it going all the way up to the leaf? Is it going up to just the blade switch? Don't really know at this point, but this does give us some information. Okay, just to recap, we've solved a problem with the port groups. So both of the VMs, Web 1 and Web 2, were in the incorrect port group. They were both in black hole. We've moved them into the correct port group, but we still can't ping the default gateway. They can ping each other. So what we're going to do now is we're going to go into the vSwitch, and we're going to verify that the port group is on the right VLAN, and then we're going to verify that the port group has the correct uplinks. So we've checked out the virtual machine, and that checks out. We've checked that the virtual machine is attached to the correct port group, and that also checks out. So now we're going to move up. So this isn't any different than what we do in physical switches and physical servers. Is we're just checking and verifying each little step. So now we're going to go into the port group, and then we're going to go to the uplinks. Let's go ahead and do that. So here's the port group here. We can see that we have both Web 1 and Web 2 in the port group. And we see that they both have MAC addresses in the port group. So this is very similar to show MAC address table for a particular VLAN. And speaking of VLAN, we're going to check to see what the VLAN is here. So that's 2024. So I'm just going to make a couple of notes here. One note I'm going to make is of the MAC address of Web 1, because we're really concentrating on Web 1 right now. So I figure if at least we get Web 1's connectivity restored, it'll probably carry over to Web 2. We'll verify that, of course. But so we're going to make a note of the MAC address for Web 1. It's 005056. That's the OUI for VMware VMs. And then Alpha Foxtrot, Beta 8, 3 Foxtrot. So B8, 3F. We also noticed that the VLAN is on 2024. This is a VLAN chosen from the dynamic VLAN pool associated with this VMM domain because we're using orchestration here. So this wasn't set by the actual administrator. This was pulled out of the pool, and the pool was set by the administrator. If we weren't doing any orchestration or integration, then that would be a manually set VLAN. But 2024, so I'm going to just make a note of that, and BA3F. So that looks good there. So now I'm going to go up to the uplinks. So this is the uplinks group, and we're just going to make sure that we have uplinks for both hypervisor hosts. So we have 72, and then we have 52. So those are the two hypervisors. 10.206.254.72 and 52 represent the management IP address of both of those hypervisors, and we don't have a name for them. And they both have uplinks. They both are trunking. So it looks like our vSwitch does have appropriate uplinks, and the links are up. So the next thing we're going to do is we're going to verify where those uplinks are plugged into. So we've checked the VM, we've checked the configuration of the VM, we made sure that the VM is on the correct port group. It wasn't, we corrected it. We checked that the port group shows the MAC addresses of the VMs, and we've shown that the port group is associated with an uplink and associated with the vSwitch that has uplinks. So, and the uplinks show link up. So now we've made sure that the packet is at least making it through the vSwitch. Beyond that, we can't say yet because we haven't checked. So the next thing we're going to do is we're going to find out what we're plugged into. So So we're in the 52 host. We're going to go to configure. We're going to go to physical adapters. And from our documentation and from what I showed you earlier, VMNIC 1, so that's the physical NIC. Again, I don't know what they call it, VMNIC, but it is the physical NIC. And we can show that that's connected to T02 vCenter, that's the distributed virtual switch. And it's got its own MAC address, which we might want to make a note of. And we're going to check. We see here we have the CDP tab and the LLDP tab. So CDP is enabled on this interface, and we can actually get a bunch of information from this. Now, this isn't always activated, but this is a good thing to turn on your upstream switches to connect to your ESXi hosts. And this orchestration that we're doing with VMware and ACI, it's actually required. It could be either CDP or LLDP, it really doesn't matter. In this case, we're using CDP. So we know that we're plugged into the A fabric interconnect because we have the name -A in there. Little trivia fact, when you're naming the cluster for the fabric interconnects, it will append -A and -B into the host name. So you just give it the cluster name, and then it'll call the A1, whatever the cluster name is, -A, then whatever the cluster name is, -B. We see that we're plugged into vEthernet 771. If we go back to our diagram, this is our diagram for our fabric interconnects. We know that we're on a vEthernet interface. So this is our hypervisor. We've checked VMNIC 1. It tells us we're connected to vEthernet 771. Again, this is something I'm going to make a note of so that we can get into this blade switch. Now, if it was a different type of blade switch or if it was directly connected to the leaf, we wouldn't have this step. Whatever blade switch you're plugged into, even if it's not a fabric interconnect, we can do these same verification steps. Just about every blade switch I know of has a way to check the interface, check the MAC addresses, check the VLANs. So that's what we're going to do next. Now we're going to SSH into the fabric interconnect. We're going to connect to the A fabric interconnect because we know from our documentation we're plugged into A. We've also verified it through CDP. And I may or may not know what the IP address of the A fabric interconnect is, but CDP will tell me. In fact, it tells me right here. It's 10.206.254.18. So I'm going to go ahead and SSH to 10.206.254.18. I'm going to set the font nice and big so we can all read it. Open up. Log in. And then here we go. So what I want to do is I want to see if the packets have made it up to this particular fabric interconnect. So what I can do is I can just do show MAC address table. Actually, it won't let me do that because I'm not in the right shell. This is if you've never logged into a fabric interconnect before, it looks like an NXOS shell, but it's not. Instead, what we have to do is connect NXOS, and then we'll pick the A side. And I can actually get into the other fabric interconnect from here, but I'm going to go into NXOS A. I'm going to do show MAC address table. VLAN, and I probably should have made a note of this, but I'm just going to verify what the VLAN ID is for this particular port group. This is the web port group, and if we take a look here under ports, VLAN 2024. So I'm going to go into VLAN 2024, show MAC address table 2024. And there we have one, Alpha Foxtrot, Bravo 8, 3 Foxtrot. That is the MAC address for the A VM. So now we know the packet has made it all the way up to the leaf, or all the way up to the fabric interconnect. So it's made it to the fabric interconnect, but hasn't made it to the uplink interface. So let's go ahead and check that out. We'll go back to the shell, the NXOS shell. So show VLAN ID 2024, and this is going to tell us where it's active. So it is active on vEthernet 771, so we know that's the correct interface. That's the interface pointing down into the blade. And Ethernet 1.2, that is actually the correct interface. If we go back to our diagram here, we know that's 1.2 there. So it is being forwarded up to the uplink. Things I'll check for is to make sure that the VLAN isn't in an isolated VLAN. That's something that actually happened to me once on a fabric interconnect. The VLAN that was supposed to be passed up to the leaf was actually an isolated VLAN, so the packet never made it to the leaf. But from all indications right now, the packet should be able to go up to the leaf. So let's go ahead and go up to the leaf now. So we verified the packet flow all the way from the hypervisor, from the VM itself, to the port group, to the vSwitch, to the hypervisor, leaving the VM NIC 1, going up to the fabric interconnect. It's in the fabric interconnect. So now we're going to go verify it on the leaf. So I'm going to open up my shell to the leaf, or to the. So right now, I'm logged into the APIC. Doesn't matter which APIC you log into, and I can SSH directly into leaf 1. So give it my password. So now I'm on leaf 1. I know that's plugged in on interface 1.2. Now what I can do is I can do the same command, show MAC address table VLAN 2024. And nothing's going to come up. Now there's a reason why nothing comes up. In ACI we have the front-facing VLANs and we have the internal VLANs, and they are different. And the reason is because ACI supports overlapping VLAN namespaces. What does that mean? Well, that means that VLAN 10 for one namespace can be a completely different VLAN than VLAN 10 for a different namespace. So for example, if we have two tenants, Coke and Pepsi, they can both use VLAN 10, even on the same switch, and they're separate VLANs. So this is useful if you need more than the 4,000 VLANs. ACI currently in 4.2 supports up to 15,000 VLANs, but that's only because it supports overlapping VLAN namespaces, because there's only 4,000 or so VLANs in the 802.1q specification, because it's a 12-bit address space. So we're going to need to find out what the internal VLANs are. Now, even on the same switch, we can have VLAN 10 on port 1 be a different VLAN than VLAN 10 on port 2. In order to do that, we need to translate them both into a renormalized VLAN ID. Now, this renormalized VLAN ID, this internal VLAN ID, is going to be different from switch to switch. Even in the VPC pairs, they'll be different. So in order to find out what that mapping is, and this mapping is ephemeral, so this mapping can actually change from reboot or even in reconfiguration. So I'm going to need to find out what this mapping is. So I'm going to do show VLAN extended, and then I'm going to pipe it through the grep command, and I'm going to grep for 2024. So this tells me that VLAN 2024 internally is on VLAN 11. Again, that's an ephemeral internal VLAN. It can change from reboot to reboot. If I check leaf 2, for the same VLAN 2024, it'll probably be a different internal VLAN. But right now, the packet should show up on our internal VLAN. So I'm going to see, well, let's see if it actually made it up to the interface. I'm going to do show MAC address table VLAN 11. There it is. We actually have both Web 1 and Web 2. So Web 1 is B83F, and then Web 2 is 9F60. We show that Web 2 is on tunnel 12. That's the VXLAN tunnel to the other leaf. Where in this case, B83F is on Ethernet 1.2. So we actually are making up to the leaf, so what's going on? What is it trying to do? We're trying to ping the default gateway. In ACI, default gateways are pervasive SVIs, which means they exist on every leaf. It's an anycast gateway. And I can verify this by doing show interface brief, and I can specify a VRF. In this case, I'm going to specify VRF T02 main, because I'm going to specify the actual tenant and then VRF. So the leafs don't actually know what a tenant is, but they do know what a VRF is. And the tenants and VRF combination are instantiated as just a VRF on the leafs. And the naming convention is the tenant name colon the VRF name. So T02 main, so show IP interface brief, I should do that. Show IP interface brief, VRF T02 main. Show IP interface brief, VRF T02, might be capitalized. Yeah, it's case sensitive. And so here's something interesting. From our documentation, the default gateway should be 10.2.1.1, but it is 10.2.1.2. So this shows me that this is probably a misconfiguration. So I'm going to go into the APIC, logged out. So I'm going to go to tenants, select tenant 2. I'm going to go to bridge domains, web, and check out the subnets. Sure enough, yeah, that's misconfigured. Not uncommon. So I'm going to go ahead and delete it. Some things in ACI you can rename or change, some things you can't. There's reasons behind that, which we'll get into this video. But I'm going to go ahead and recreate it. So it should be 10.2.1.1 according to the documentation. I'm going to do advertise externally because we're going to route this out a little bit later. I hit submit. Now, let's go back into the VM itself. I'm going to open up the console. I'm going to ping 10.2.1.1. And there we go. And now we've resolved the issue. And just to be safe, I'm going to go to Web 2. I'll do the same thing. I'll go into the console. Now I can ping the default gateway. I can also ping other default gateways in my VRF. So that's the database bridge domain. So everything looks like we resolved the issue. So I would mark this ticket resolved, and I would kick it back, or I would mark it I think it's resolved, kick it back, and have them verify. But this actually did fix the issues that I broke. So it helps understand how things work inside of ACI, but it also, it's not rocket science. We're just verifying every little thing. So when the usual suspects don't pan out, then we do the procedural verification and checking, and we just go through every little step to make sure that everything's configured correctly. In our case, we had 2 misconfigurations, one in VMware and then one in ACI. And that's not uncommon that you'll have multiple things incorrect. So I hope this helps you out. I hope this shows you a little bit of what it's like to troubleshoot in ACI. It's not magic. It's not rocket science. It's pretty easy once you have the map, once you have how things work inside of ACI. So